Hello, everyone. I'm Katerina Nesvit. I'm founder and CEO of AliveMath and associate professor of the data science, college business, innovation, leadership, and technology in Marymount University. And I will be talking today about supply chain risk prediction with Neo4j graph data technology. So let's get started. First, I will mention where I met the graphs. I started using this technology about 10 years ago, and what especially resonated with me that in the tables we don't have verbs in between. I worked on a couple of projects in social media, in healthcare, and then I started my own company where I developed the data science system using the Neo4j graph. So I will show you what inspired me, and I hope it will make sense to you. So we work with data in the tables, and we build a connection during the query time. We build this, but we know that the time is expensive and it costs money. Any business model, we already have the connection in between. Going back to the past, in 2021, the graphs was used only like 10%, and now it's 80% of the market. So let's take a look on performance. When our business model gets complicated, it might not even be finished by the time you need that. But with Neo4j, it stays consistent, stable, and you can build any complex question and use this technology and have results just in seconds. So let's dive into detail of their data field. I use the supply chain, and the reason why, because it's on the daily basis we move food, medications, everything around us. Basically, we move goods, information, and money. But on the path between, we might have disruptions. It impacts the logistics system and, of course, financial aspects. I will start with the table data and show you the data modeling first. So it's critically important to set up the driveway before we go to the drive, actually. So we start with a port located in country in the region. So that will be our data model for the ports. I have a link over here if you would like to replicate that later on. And this one will be the query to upload the data into the graph so we can see all the information will be located into the port. So we have weather risk and capacity, everything is in the node. So we would have ports, countries, and 5 regions. This is our result, what we can see once we upload the data into the port. Next, let's dive into the relationship. So in here, you see the port starts and ends the relationship between the ports. So it's a shipping route in here. And the Cypher query will be, we connect origin port with destination port. Again, all the information inside their relationship is already exists. So disruption probability, season risk, and alternative routes, everything already in there. So that is how it looks if we take a look on the information in between the nodes. The shipping route, you can see the disruption probability is over here. And it's about like 77 major trade routes shown in here. So This is our knowledge graph that we built using the data model. And the data is from transportation statistics, port performance, and international trade databases. And let's get dive into a little detail. So geographic distributions, it's 5 different major locations, and the road coverage, Asia, Europe, and yeah, a lot of different things. So next, I want to highlight the risk. The risk is very important. Say in gymnastics, we should have the safety pillow in case we fall. And remember, we had Amazon services crashed and no one was ready for that. So when we predict a risk, we actually really help to investors, insurance, everyone to get that safety step to move on and be successful. So it's really important to have this crisis management intelligence. I will cover the highest risk, weather-sensitive roads, port centrality, a little bit efficiency analysis of the ports, and emergency rerouting scenarios, alternative roads, and a lot of things that could be potentially calculated with this big topic. So here I start with finding highest risk for the roads using the combined risk score. So between much port, shipping road, and port 2, we combine disruption probability, risk score for the port 1, and the risk score for the port 2. Combining the risk over here, what we see immediately, there is one critical thing here, one backup option in high risk. It requires immediate attention. Next, what would happen if we combine high traffic, low alternative? We might get very critical things. So when we use the where statement, we can select trade volume high with alternative roads with less than 2. This is also very helpful for us to see where to focus our business attention. The next slide, I show you find the most ports that would require attention. Let's say we compare our global average 12 hours to these laggards in Africa. It's 32 hours. It's almost like in 3 times. It's time equals money. Again, we should have our focus in here to avoid the major issues so you don't get in trouble. The next, weather. Weather changes every single day. So much port, shipping road, another port where season risk is high, or the weather risk in the port 1 or port 2 is high. We get results with expected delays, and as a pattern, what we can see over here, the origin port matters the most than the port of the destination. That we see unexpected delays over here. The next one, we can analyze our global network and calculate the port in general, like on our annual capacity and how many roads will be in there. So again, we could see that the high road count with higher capacity, it will exponentially will have higher disruption impact. And the only way how we can see it is analyze our knowledge graph and request the information we need and get in seconds, order it by disruption impact score, our data in results. The next one, I want to show you capacity and performance, because sometimes it's really tricky to find the right answer. And of course, we would like to have the low risk, but the average capacity we need to get higher. But depending on each situation, whatever you need a speed, whatever you need capacity, whatever you need a low risk, you can choose your best option. And what I can say, the trade-off exists. Capacity can go higher with a lower risk. And what you would do in a case of emergency. Emergency happens and might happen very unpredictable way. So remember, we have all the information inside our knowledge graph. We just need to match and find the best alternative way where it potentially can get affected as an alternative port. So we can have our rerouting scenarios. And we can find this very fast and with a low risk. So we can be more proactive, we can have preparation and set our expected course of action, what we have to do in case of emergency, so we can be ready for that. So what this approach does is we can do a lot of risk analysis to calculate the different risk in the ports and the roads. We can predict the weather risk, any changes in the climate. We can also have the network analysis together with the performance analytics and find the alternative roads with enough capacity that you need, the speed that you would require to have, and the major thing is to optimize the results by the needs that you need right now. And what I like the most is the emergency planning, because this is something that people will mostly put a lot of attention, because you would need to be prepared for any kind of situation. And when we invest our money or time, we would like to know what will happen. And the graph will show you the different options. So you can predict the disruption impact in order to avoid any cascade effect and analysis. To analyze the different scenarios, what will happen. So I'm going to record, it was very brief talk, but I'm going to record on each single topic, additional video explanation and how to calculate the risk and how to predict the outcome for their supply chain. And it's going to be like a series of videos and explanation. So I would like to stay connected. Here is my LinkedIn QR code. Let's connect, and I would like to have some conversation and maybe discussion on the real data in this field. And thank you so much for attending today. That was very special for me to share this knowledge graph with supply chain field.